Ever wondered why your phone's camera sometimes mistakes a shadow for a person, or why self-driving cars freeze in a downpour? That's the challenge of domain shifts, when AI models trained on one data environment struggle in new, unpredictable conditions. Today, we're diving into a breakthrough called PDAF, a method that's revolutionizing how AI adapts to the real world. Let's unpack why domain shifts are such a big deal. Imagine teaching a computer to recognize cars using only sunny city photos. Now test it on a foggy highway or a nighttime street. Suddenly, it's guessing instead of seeing. This is the core issue with semantic segmentation, the process of labeling every pixel in an image. Traditional models act like students who memorize answers for one test, but panic when the questions change. Enter PDAF, short for Probabilistic Domain Adaptation Framework. Think of it as a smart guidebook for AI. Instead of relying on specific examples, PDAF teaches models to understand the rules of different environments. For instance, it learns how rain distorts vision or how shadows shift at dusk. This allows AI to adapt dynamically, much like a human driver adjusting to weather changes. So how does PDAF work? It's built on three key components. First, the Latent Prior Extractor, LPE, acts like a detective. It compares images from different domains, say, a sunny street and the same street in fog, to identify hidden patterns. Next, the Domain Compensation Module, DCM, uses these patterns to fine-tune the model's vision, smoothing out distortions caused by environmental changes. Finally, the Diffusion Prior Estimator, DPE, takes it further. By leveraging diffusion modeling, a technique that teaches AI to clean up noisy data, PDAF can infer domain rules even without perfect image pairs. The results? PDAF is a game changer. On challenging datasets like BDD100K, which includes real-world chaos like fog, snow, and neon lights, PDAF outperforms models like DeepLab v3+ and Mask Deformer. But it's not just about accuracy, it's about robustness. Whether it's a self-driving car navigating a storm or a medical AI analyzing blurry X-rays, PDAF ensures models stay reliable, even when the world gets messy. This isn't just a technical upgrade, it's a leap towards safer, smarter AI. From autonomous vehicles to disaster response drones, the ability to adapt to new environments could mean the difference between a system that works everywhere and one that fails when it matters most. PDAF shows that by thinking probabilistically and learning the hidden rules of data, we can build models that see the world more like humans do. So what do you think? Could probabilistic modeling be the key to smarter AI? Drop your thoughts in the comments below. And if you want to explore how PDAF fits into the bigger AI picture, hit subscribe for more deep dives into the science behind the tech. Until next time.